Hello everyone, I'm Yogesh Panchan and this is our subject Engineering Graphics and Design. Today I want to discuss on chapter Projections of Planes, and today our topic is Introduction of Projection of Planes. Projections of Planes. What is plane? A plane is a flat surface with negligible thickness. There are only two dimensions of plane, length and width. So actually we consider the thickness of the plane is negligible because the thickness of the plane compared to length and width is very small, so that's why it is negligible. So in this chapter we want to take the projection of 2D planes like square, rectangle, triangle, circle, rhombus, pentagon, hexagon, and elliptical planes. Now, square is one figure in which all the sides, means there are four sides of square are equal and the length of its two diagonals are also equal. The midpoint of two diagonals is a one point which is center of square. A rectangle which has a longer edge and shorter edge. Triangle, there are three types of triangle we will study, in which one is equilateral triangle, isosceles triangle, and right angle triangle. Circular plane, so for that circle we want need the radius or the diameter. To draw the rhombus, we need the longer diagonal and shorter diagonal. For pentagon, which is a regular pentagon, it has five equal sides. Hexagon, six equal sides. And for ellipse, we need major axis and minor axis. Now, here we are going to study the projection of plane when the plane is located in different condition with reference to its reference plane like HPVP and PP. So our first case is when the surface of the plane parallel to HP and perpendicular to VP and PP both. This is vertical plane and horizontal plane which is perpendicular to each other, and at presently we are using first quadrant. The intersection of horizontal plane and vertical plane, that line or the corner is known as XY line. Now consider one rectangle plane of any size of its longer edge and shorter edge. The name of the corners A, B, C, D. Here A, B and C, D shorter edge and B, C and A, D longer edge. So this plane is placed in first quadrant in such a way that the surface of the plane is parallel to horizontal plane and perpendicular to vertical plane, and it is also perpendicular to profile. Now when we observe the rectangle plane from here, the projection of ABCD on vertical plane, and keep in your mind we are taking always orthographic projections. Orthographic projections are those projections which are always perpendicular to plane of projection. Here I want to take the projection of this plane on vertical plane. So the projection from A to vertical plane, that projection line is always perpendicular to VP. So take the projection from A, B, C and D. Because AB line is perpendicular to VP, the projection of A and B both are at the same point, and CD line is also perpendicular to VP. So the front view of C and D projected on the same point. So the projection on VP, A dash, B dash and C dash, D dash, when we join that projections with straight line, we will get this type of line. This line is known as front view, means the projection of the plane on vertical plane. When we observe from top, the projection of plane on horizontal plane is ABCD, and when we join this ABCD, small ABCD, we will get this type of plane on horizontal plane. This is top view. Now from top view, because the plane is parallel to HP, the top view is true shape of rectangle, and front view is line because our surface of the plane is perpendicular to VP and parallel to HP. So these are the projection projected on HP and VP. But when we move this horizontal plane clockwise 90 degree, and VP and horizontal plane keep in the single plane, you will get the projection front and top view. So in 2D, always we draw like this. First of all, draw XY line. Then draw the top view ABCD true shape ABCD. Take the projection and draw the front view A dash, B dash, C dash, D dash. Now here keep in your mind that whenever we observe front view, the horizontal plane looks XY line and the projection on vertical plane is A dash, B dash, C dash, D. So here this plane is vertical plane and XY is represented as horizontal plane for front view. But when we observe top view, the projection on HP, this view, and when we observe top view, vertical plane looks XY and projection on horizontal. Okay. Let's say another condition when the surface of the plane parallel to VP and perpendicular to both HP and VP. So this vertical plane, horizontal plane, XY line, and now our plane placed on first quadrant in such a way that the surface of the plane is parallel to VP and perpendicular to HP. So when we observe front view, the projection of A, B, C, D on vertical plane, A dash, B dash, C dash, D dash, and when we join with straight line, we will get true shape of surface on the vertical plane. And when we observe from top, the projection of A and B at same point and projection of C and D at same point. So here A, B, C, D, and when we join these points, we will get the straight line. So by moving the horizontal plane clockwise, we will get the front view A dash, B dash, C dash, D dash true shape and top view line. The surface of the plane perpendicular to both HP and VP but parallel to PP. So in this time, our surface rectangle plane is perpendicular to VP and perpendicular to HP. So it is automatically parallel to profile plane. So front view of this plane on vertical plane looks vertical line A dash, B dash, C dash, D dash, and top view the projection on horizontal plane ABCD is also line. So in 2D projections, always we take XY, front view above XY and top view below XY because we are considering first quadrant. So here by moving horizontal plane, the top view below XY ABCD. So when the plane is perpendicular to both HP and VP, the front view and top view both the views are straight line. Surface of the plane inclined to HP and perpendicular to VP. So here horizontal plane, vertical plane, XY line. And when we keep the plane in such a way that it makes angle with horizontal plane and the surface of the plane is perpendicular to VP. So here theta is the inclination of the surface of the plane and our reference plane HP. So for front view, the projection of the plane on vertical plane line, because the plane is perpendicular to VP, and the front view A dash B dash C dash D dash is make an angle exactly theta. Top view of the plane on horizontal plane ABCD. Now here the top view of AB is true length, same as the original length in capital AB of the plane, but the length of BC in top view is less than the original length of plane BC, because the line is inclined to horizontal plane. So its projection is always less than 2 length. Here AB is equal to CD and AD is equal to BC. In 2D representations, first of all, draw XY, then draw one horizontal reference line, take any point A dash B dash here, and angle theta, the length of this line is equal to true length of the longer edge of the rectangle. So this is front view. Now by moving horizontal plane clockwise 90 degree, the top view goes below xy. So here for below xy, we take the projection from A dash, B dash and C dash, D dash vertical line and draw one rectangle. But this top view is not a true shape. Now surface of the plane inclined to VP and perpendicular to H. Horizontal plane, vertical plane, XY. Now keep a plane inclined, the surface of the plane inclined to vertical plane and perpendicular to HP. That angle is represented as phi. Now first you take the top view, means the projection of plane on horizontal plane. This is only line ABCD. The line is also inclined phi angle, whatever the original angle between the surface and the vertical plane. Now front view on vertical plane is A dash B dash C dash D dash. In this front view, the length of A dash B dash and C dash D dash remain true length, but the length A dash D dash and B dash C dash will be reduced because this edge is inclined to vertical plane, so the projection on vertical plane will be reduced. Now in 2D representations, this is XY. First of all, draw the top view. This is only a line. The length of this line is equal to true length of longer edge of the rectangle plane, and it is inclined at phi angle with VP. Front view, which is a rectangle but not a true shape. Now the very important position of the plane, surface of the plane inclined to HP and VP both. So here vertical plane, horizontal plane XY, and keep the plane ABCD in such a way that plane is not parallel and perpendicular to any reference plane. This plane is inclined to HP as well as VP, means inclined to both the reference plane. So top view, the projection of plane on HP, ABCD. This is not a true shape of rectangle. And front view on vertical plane is rectangle. This is also not a true shape. So after moving clockwise 90-degree HP, you can draw ABCD and front view A dash B dash C dash. This is the front view and top view when the surface is inclined toward the reference plane. Okay, thank you very much for watching this video.